Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
People just don't do this. And there's been a lot of work. Ben Schneiderman's here. He's done a lot of the early work on this, on labeling lots of pictures at once. And one of the principles that we use was clustering based upon time. And we cluster based upon time by pulling these pictures that were taken around the same time into a stack. And then we break that stack when there's a big gap between when the pictures were taken. And that makes it very easy for me to kind of look at all these stacks and say, oh, let me recluster this and see when these were taken. And it's very easy to see now that these pictures were all taken at the same event. I can pick on one of those pictures, assign a keyword to them all at the same time. And that really goes a long ways towards helping people annotate, at least by event. So with the automatic analysis, with this clustering all to assist you, and then finally with things like you can use these all in conjunction with each other. So we can say near a certain date, I can filter, and then I can say similar looking pictures. So I can click there and say all those looking. And sometimes it's not exact, or you can kind of play around with it and get things that look more or less like it. Okay, we had two feedbacks on, well, at least two feedbacks from our users on this. Let me switch to this. And the two feedback were addressed in this next prototype. And those were that, how do you deal with tens of thousands of pictures, one of the things that we really set out to do, when as you're dealing with more and more pictures, the pictures get smaller and smaller, those thumbnails. You have to have some way of scoping it. Sure, you can say, oh, I only want to deal with 200 or 300 pictures at any one time based upon date. But was there a way really that we could deal with our entire collection? So that's one of the things we set out to do. The other criticism really was that while you give me these great annotation tools, I still don't want to take the time to annotate my collection. So how far can we push views that let you browse your photo collection, yet still don't require you to go to that effort to annotate your collection? So what we did in this next work, this was work done with David Hun from MIT, who was an intern last summer, actually 2 summers ago, was to divide up the collection doing that same clustering based upon time. So you take your unclustered collection right here, and then you just divide it up at a time, and you cluster them adaptively. And I won't go into any of the algorithms here. You can look at the paper, or you can see some websites about this and a video. All the videos will be made available also. So you take those clusters, you lay them out in a timeline. But when you lay them out in this long timeline, it doesn't make very good use of screen real estate. And it was one of the first things we tried, and people kind of liked it, but it scrolled off. So we wrap these clusters to columns, like you're reading a newspaper. And as you read that newspaper, you go from one column to the next column to the next column. But that still doesn't address the fact that the thumbnails are very, very small. So what you can now do is you can pick a representative thumbnail for each of those clusters. And there are some other places that are working on good algorithms for picking a good representative thumbnail of a population. In our case, we just picked either the first one or the middle a user settable parameter for the cluster. And then we represent the clusters over here by a scaled thumbnail that size. So it's really best seen, as all of these are. So here is a view of all my, actually these are Curtis Wong's pictures, the head of the group. And I can very simply zoom into these pictures. And as I zoom into them, let me make this bigger. So as I zoom into them, the thumbnails are replaced with the constituent groups. So you can see here that I can browse this collection very quickly. And there's some attributes that I'd like to point out about this. One is, again, this is about 4,000 pictures that I'm browsing through very quickly. The size, as I said before, is represented by the quantity. So I get a good notion that there are a lot of pictures in these collections. They might be important. But even more so, it creates a kind of landscape that I start to get familiar with as I browse it. So for instance, I know there's a picture of the pyramid at the bottom of the Louvre Museum right here. And I can just go very quickly into that, just because I know where that was, because I know this sort of landscape, and that sort of spatial memory is very important in browsing the collection. Also, that as I zoom into these collections, if I didn't like that this is a particularly representative picture, I can choose another one and can say, oh, that's much more representative of what makes me remember this cluster. And so it's very settable. And so over time, I start to get to know this even better. And also, I start knowing where there are pictures behind these representative photos. So I actually know that if I zoom in on this fruit, I can get to a picture of a bed that's kind of pretty in the Louvre. So again, we did user testing on this, and that's always important. I don't want to go into the details of that part because we've got other things to see. But it's important to try out these interfaces because this interaction with real photos, your own real photos, not some fixed set of photos, but your own photos, is really important. And we need to build those interfaces that respond well. And that's really one of the points that we're going to get to later on with Avalon, is that we want to be able to build those prototypes quickly. So let me close this and go on to the next demo. I'd like to introduce Mira. And this is a different domain. So let me start this demo for her.
This one. I can start it.
Okay. So this is a different domain. Photos are a very interesting domain, but also presentations and slides and any graphical system is an important domain. So take it away.
Thanks, Steve. So last summer, we looked at presentations, and more specifically, what happens in a presentation. So all of you are here today. However, some of you are listening to me, and some of you are not. And most of you have laptops. And so what would happen if everyone had a laptop? What kind of interface would be most useful for the viewer of this presentation? And so we call our system V for V, a view for the viewer. And in V for V, we represent the deck of slides as a three-dimensional stack. And the user can very quickly move through the slides by moving the cursor over the deck. They can go forward and backward with these arrows on the left. But furthermore, they can click outside of any slide and zoom out and see the whole deck. And so they can very easily select a slide, look to it, and then move to another slide. Now, of course, if the presenter is really good, you expect that you'll start out synchronized. And so as they move forward, the viewer's slides are going to advance automatically. But at any given moment, the viewer can pause and the presenter can continue. And so in the top left corner, you see a window that actually shows the presenter's current slide. And so the viewer can now go back and look at a previous slide or perhaps annotate. And we provide annotation through digital ink, so the viewer can draw, or they can write text, or they can flag the slide as important with this red tab. And what happens when they flag the slide as important is that when they now go back and look at something else, this slide is no longer put back into the stack. And so it essentially splits the stack and allows the user to organize the stack according to their preference. Note that the order is has not changed. The order of the slides is still top to bottom, front to back. And so with that, I think we'll go back to the next demo.
Probably can't hear me, but George, so the next thing's about some very, very recent work on using Avalon to do the rapid prototype.
Well, good morning. My name is George Petchnik, and I just recently joined the NextMedia group as a product designer, and so I'm probably in a very similar situation than everyone here in the audience. I came to this team, I'm confronted with those two really interesting prototypes. You see on the one side, Stephen Drucker's media frame and organization of digital photographs. On the other hand, you have Mira, who has some really interesting ideas going around with showing slides for the viewer. And I thought, I'd like to join into that fun and at the same time explore a new technology called Avalon that's being developed here at Microsoft. And so what I did is I started looking at the question. So Mira looked at how does one viewer look at one PowerPoint presentation. What I wanted to look at is how would I visualize all of the PowerPoint presentations I have on my system. As a grad student, I know professors are starting to use more and more PowerPoint, and I'd like to just get an overview of every slide I have on a system. So I started just mocking out some ideas. So I tried out like an exhibition view. You can see in the top left corner, or rotating DNA strand. Since I only had a week to prepare, I went ahead and took a more easier approach, the exhibition view you see in the top left corner. And I went to 3D Studio Max, which is my preferred tool for 3D modeling, tried out some different parallax views, tried to get a feeling for how the space and the slides would work together. So this was like one wide spacing view I tried out. This is a different arrangement with where the big rectangle would represent the title slide and the small rectangle would represent thumbnails. And the next step then was to actually take some of those concepts and bring them into Avalon. So let me switch over here to my other PC. So here you can see this is work that I did over the course of 2 days. Then I started learning Avalon, which is a scripting language. It's more than that. It's an entire user interface framework that combines 2D and 3D elements. And I went ahead and just arranged my slides in 3D. As you can see, there's some basic interactivity there. And what is nice is you can actually animate all properties in an Avalon scene. So here, I have a little code snippet that creates a storyboard that will animate one of the camera properties. And when I then paste this into this Avalon viewer, you'll see that the slide then automatically animates. So the nice thing here about Avalon is it allowed me to join this team, explore different ideas, and go from a sketch to a user interface in just a few matter of days. Thanks. So, yeah. So coming up is Greg Schechter. He's an architect from over in Windows, and he's been instrumental as sort of the mastermind behind all of Avalon. And he'll give you a good introduction.
Thanks, George. So let's see. So yeah, my name is Greg Schechter. I'm an architect on Avalon, which is part of the Windows Client platform, and I also work on the Longhorn Desktop Window Manager, which we'll be seeing as part of Longhorn. So we only have 30 minutes or so to go through Avalon, and there's a lot of stuff here, so this is going to be a very fast tour of it. I want to give sort of a high-level point, talk about a bunch of go through a bunch of demos, and then drill into some technical tenets of the system. So overall, what is Avalon? It's a new client-side runtime presentation for the presentation platform. It's an SDK as well. It plays the role of a lot of these other systems that I mentioned down here: MFC, WinForms, Win32, User and GDI, that entire stack. And some of the goals are to really bring together a couple of a lot of the benefits that we see from client-side programming and web-side programming. So for client-side programming, clearly you have local processing resources, you have rich graphics and powerful GPUs that are becoming ever more powerful. Support for animation, because it stresses both of those things. Support for local storage and offline usage. And then from the web, we've seen over the last 8 or so years real benefits from web applications, the opportunity to deploy applications easily, to update them easily, declarative support via HTML and DHTML, and a better security model than is typically the case on the client side. So Avalon, what George showed in the little code snippet was something called Saml, which is a declarative markup, and Avalon applications consist of that. Their UI is generally structured via that sort of markup, as well as code that interacts greatly with that markup. And I'll talk more about that in a bit. Avalon is available on Windows XP and Longhorn. It'll be available in 2006. Right now there's community technology previews out and available. And the demos I show are built upon what's out and downloadable today. So some of the challenges of building a new presentation platform is there's a lot that needs to be covered. One, you have to be able to run in a window as a local application. You have to be able to run in a browser as a web downloaded application. You've got to have a really solid application model so that you can build your applications, means of deployment over the web or otherwise, support for documents and advanced text and typography support. Graphics, media, and animation really have to stress and use the whole what the GPU is providing, what the power that's there on your client. And without performance and interactivity, such a system is not very useful. And we talked about online and offline. So I'm not going to read through these. I'll talk about these in more depth in a moment. So a couple demos I want to start out with is this is not a very interesting demo, but I'm showing it to show that Avalon applications can run inside of the browser. And right now, I just went to a local .xapp file, but this could have been web deployed as well. And if it were web deployed, it would come down onto the client system, install itself, check to make sure it's in the security sandbox that allows for applications to come down without you saying, yes, I'm willing to let this code run on my system, and run. And now, let's see. So this is very simple. It's just showing some of our 3D graphics and vector graphics support. And what do I have here? I'll hit on that. And I'll quit the app and go on. Now another one, a more sort of classic Avalon demonstration I want to show is this, which if you think about a storefront type application, a web storefront type application, there's a lot of submit to the web server and retrieve HTML back and such. And we know that this can be a lot more interactive than that experience. So this is an example where we have a variety of things that you can purchase. And what this is going to do is it's going to hook up to the Amazon.com web services. So I move in here, I select my category. For some reason, something's not quite showing right here. But let me do this. You can see as I zoom in that the graphics remain high resolution. That's because this Avalon really encourages the use of vector-based graphics, which are resolution independent. Here we've got a little 3D icon that does its thing when you click over it. And over here, this is not particularly high quality because this is just an image on here. But the application can not clearly be modified to use vector-based graphics for this as well. So I'm going to go in here. I'm going to search for REM, let's say, and hopefully it'll go out. And what you see in the background is sort of a slowly moving. There we go. So let me first do this. So what it did is it hit a Amazon.com web service and then used Avalon support for data binding to a list box. And this is effectively the 2D list box that it's bound to, but it's styled in such a way that it has a unique appearance. And I can go and move between the different albums, or I can put it into this other mode, which is providing a 3D mode. Now, one of the things that's really important about this is the programmer of the application doesn't think that they're using a 3D view of this particular list box. It's just a 2D view that they program against as has a selected item, a current selection, and the list of items. And separately, designers have come in and replaced the visualization for this list box with a 3D view. The back of the case here is just generated as a 3D texture with the songs that have been also received from the web service and data bound from the web service. Another thing to show here is this little guy is just a 2D element that shows some opacity and opacity gradients, and just the ability to use elements like this in 2D UI and use them in a fast way. All this is taking advantage of the underlying graphics hardware. Okay, so one of the things that drives a lot of the choices that we make in Avalon, how Avalon was built, was integration. And this is integration at a variety of levels. One is for application model and the control model for how applications are built and controls are defined and laid out. Another is document support for typography. And the third is the graphics model, the graphics and media and animation model. All of these are built consistent, self-consistent with each other. That doesn't just mean that there's only a few APIs. There's an awful lot of APIs, but they're all built consistently. From each of those three models, there's some key aspects to each of those three components. For the application side, we have a composable component architecture, meaning that the controls that you have, so for instance, a grid control can host other components inside of it. You can host a button inside of a grid, and inside of that button you can have another grid, etc. Those are all composable. Layout services are provided insofar as applications and third parties can define their own controls that participate in the same layout mechanisms that the stock Avalon controls participate in. We have data binding that works in both directions, both from XML data sources, SQL data sources, from CLR.NET objects themselves directly. And it's two-way in that clearly they feed the UI, but as you make modifications and edits on the UI side, they can transform back into the original data source. It's transformable as well, as you can stick functions in between there and have the functions transform the data. And rich visual styling and theming, I gave an example of that with the 3D visualization of the list box. The graphics model, 2D, 3D graphics, imaging, text, video, and audio, that's actually the area that I'm most involved in. And I'll talk a little bit more about the composability of that. But the composability of the aspects of graphics really lend a lot to the richness of the system, what you can express. And finally, the document model. There's support for very rich open-type typographic services, fixed documents, flow documents that in advanced pagination support, digital rights management, a container format, that .zap application that I showed is effectively a container that contains both the application and all of the media resources necessary to run that application. So what George showed earlier was, what do I want to show here? What George showed earlier was this thing we call XAML. And it's an interpretive environment in a way. And what I've got here is a button. I don't know if you can see there. I'm clicking on the button and it's changing state somewhat. But a button that has a chunk of text below it. Now, this XAML is just a developer tool for us. It's a semi-interpretive environment. You make a change here, and it goes and reloads this XML, which this particular XML is this markup language that we call XAML. And this is the entire construct for this construct. We've got a button with a stack panel, a video element, and a text below it. There's no code here. There's no interaction, but you can hook up code to this, and I'll give examples of that. Another one I wanted to show is this. Now, 3D aliasing is bad. We know that. So we've got to deal with that as well. But what we've got is is that text visible? Okay, great. So what we've got is a grid that has a paragraph in it, and then finally, there's a bunch of stuff here that builds a 3D view that uses that paragraph and puts it as a material on the brush. Now, one of the things to notice about this XAML markup is I'm going to make a change to it, but typically we don't expect this to be handwritten and hand-edited. It's very much designed for authoring and editing by tools. So, but one of the things I do want to show is here we've got a 2-column document that's paginated for 2 columns and is moving around. If I change this column width to 200, 200, 3 columns fit on there. So you can see that this is really live content going on here. And in this particular case, there's nothing changing on the display, on the page, but there could be video as part of that and user interface. The XAML pad or the rotating? No. Well, this is definitely just a technology demonstration. It's definitely not. The applications of specifically putting the text on the 3D like that, I think some of them are the Media Mania demonstration that I showed with the back of the CD case having the data-bound list of titles. But this really is more of a demonstration of the integration aspects. One of the things I'll also show is another demo in a moment that clearly shows that you can come up with not as good UI as what some of these guys who were just talking earlier are going to come up with, and I'll describe that more in a minute. Now, this is another interesting one that shows the power of the data binding system. So this is just a very simple, I'll just show the code here, the markup. This is the entire markup for this. And what this is live RSS feed that came in and is laid out according to the markup that I just showed. It lets you select through the different articles that came off of this RSS feed. So let's look at that for a second. We've got an XML data source that's sourced to an MSDN RSS feed. And then bindings from that RSS feed into the document, binding XPath title, etc., which constructs this entire user interface in just this markup. There's no code involved. Again, to show the flexibility of the system, I can go ahead and change foreground. The foreground of this, just a simple modification that just gives it a slightly different look. So a lot can be expressed declaratively in Saml and in Avalon. And so far we've seen no code, but obviously code is a critical part of all this, and we'll get to that. On the graphics side, the GPUs are getting more and more powerful at a faster rate than CPUs are at this point. And Avalon is really built to take advantage of that. Everything you've seen goes through Direct 3D ultimately and is rendered through hardware. We do also have software rendering for when hardware acceleration is not available or for when video memories run out, etc. So Avalon provides capabilities for 2D and 3D graphics, for image effects, for pluggable codecs, for imaging itself, of course. Hardware accelerated subpixel clear type, just another way of saying just very high quality subpixel rendered text. Video and audio support we've seen, and there's really an ability to animate pretty much anything in the system. Any property of any object can be animated. There's also a remote ability story. What's going on with all of these applications and all uses of Avalon really is we're building up a structure, a display list or a scene graph as the response of running the application code. That scene graph can be remoted to another machine so that it can update and do autonomous just receive edits to that scene graph remotely in order to do what you get here, rather than sending bitmaps or graphics commands for every frame. So there's a lot of opportunity there as well. There's an aspect of future-proofing to the whole system as well. Resolution independence is key to what we have. When you program in Avalon, the coordinates that you provide are physical coordinates in terms of fractions of an inch. They're not pixel-based coordinates. So as displays get higher and higher resolution, you get the higher and higher rendering quality as well. And there's a deeper color pipeline in the system as well. There's support for the sRGB color model, which is a floating point color model. So the demo I made reference to a second ago about not necessarily the best UI for doing the job. This is an example of that. this is a cool, I think this is a cool demonstration of both imaging and 3D in selection. But it's not as necessarily usable as what Steve showed earlier. And the point of this is that the UI toolkit is there and available, and the runtime is there to provide, to do with what you will and come up with good user interfaces. But this is showing that from a 3D perspective and from an imaging perspective, we are handling quite a few images quite quickly. We've also got a moving 3D texture in the background that is clearly live because I can do things like this, all built with vector-based elements. This is another example that showing video, really showcasing video. In the background, we've got a high-definition video stream playing, and then we've got a number of video streams playing as textures on spheres, really pushing a lot of bandwidth through the system. The glitching we see has to do with hit testing of 3D. So if I move the mouse away, that goes away. And that's actually fixed in newer versions. So there's a Saml markup that I showed a number of demonstrations with. And the point of it is that it's easy to learn, read, and write, but the intent is really for tools to generate it. Effectively, all it is an object instantiation language. So you really shouldn't consider it a first-class language in its own right. It's really all about instantiating objects. And what it allows for is for code and content to be separated so that designers and both visual and UX designers can work on the Saml side either through tools or directly, and code can be generated. Or you may have websites programmatically generating Saml as well for interpretation. Here's an example. Well, and because of the declarativeness of the system, it's easy for tools to consume and generate. Not just because of the declarativeness, but also because of the minimality in the system. There's more or less one way to do things, not a half dozen ways to do things. So this chunk of Saml, button width equals 100, so we've got a 100 unit button with the content OK and a background color of light blue. This is all valid XML syntax that conforms to Saml. In C#, the way this would be constructed is it takes the element tag and constructs an object of that same type. So it builds a button, sets the content property to OK, the string OK, and builds a new brush, a solid color brush in this case, from the light blue color, and sets the width to 100. VisualBasic.net, it's exactly isomorphic to what we see in C#. So all of the Saml examples that I showed before are doing just this. They're constructing objects or setting into properties. Now, going into some aspects of the system. Graphics, I mentioned, is the area that I'm most involved with. Media integration is a key part of it. There's a couple of elements I want to touch on here. One is this notion of resources. We've got a variety of objects that you code with. Brushes, geometries, 3D models, transforms, drawings, and images that are all shareable objects. And you can modify any property of anyone at any time, and the right change propagation happens through the system, and everything's updated appropriately. There also can be made immutable if the application knows that they don't need to make any changes, and by doing so, you gain some performance benefits because you don't have to have listeners on there and such. The aspects of composability are really built around classic object-oriented notion of abstract classes. All those classes that I just mentioned, those are all abstract classes. A button, its background, takes a brush. It's not necessarily a solid color brush. It might be a gradient brush. There's a variety of subclasses of each of these that are mix and match with respect to the other subclasses in where they're used. And that really provides a lot of the a lot of the composability of the system. And the composability, an example of this is I can take a 2D UI. I can take that Media Mania UI that we saw where you select music, videos, games, etc. There's a 2D representation of that thing. I can map that onto 3D. And I can put that UI onto 3D. I can then take that 3D and project it back down to 2D, take that 2D, tile it, use it as a brush to fill an arbitrary shape, etc. You wouldn't necessarily do these things, but the composability of all this gives you the power that, that Avalon provides. Resolution independence, I talked about briefly. It results in providing scalable UI that can easily be magnified and give you higher and higher quality at greater magnification levels. It encourages the use of vector content. Much UI is built with images today which are not inherently resolution independent and pixelate on the way up. We expect that to be the case for some time still, but we want to really encourage the use of vector content and provide the tools for vector content. Animation, there's support for animating any property. We saw demos that all the animation in those demos are just doing just that. They're animating properties of various objects. We have a concept of a storyboard. Storyboard, animating individual properties of an object is not that interesting in and of itself. What typically the application wants to do is on some event, on some timer, on some trigger, on some user interaction, they want to simultaneously manipulate n different properties. And storyboards provides for a way of collecting that information in one localized place. There's also a continuous time model of animation. So, the color, you may set the color property to go from red to blue over 3 seconds. You're not defining frames. You're not just defining at this frame it's at this level, at this frame it's at this. You're saying red to blue over 3 seconds. So the more frames that are generated, the smoother your continuum of color animation is. And in a way, this is resolution independence in the time domain. Just like we have resolution independence in the space domain for vector content. Some more tenets from the control infrastructure side of things. We talked about visual styling, the ability to take a control and give it a different visual representation without modifying the client code that's accessing that UI. And hot swap visualizations, I just mean by that the ability to just randomly take in a different visualization, have that continue to work with an existing application. Layout infrastructure, we have a measure and arrange pass that all controls participate in. And there's a variety of controls, grid controls, stack panel, flow panel controls, containers really for other controls that are in charge of their layout. Layout currently is strictly a 2D thing. In 3D, we do not have a layout system. We've seen, for decades that there hasn't yet been one that's shown to be a useful 3D layout model. So we're hoping that will come up, and when it does, we'll put that in a subsequent version. So third parties can build their layout behavior that plays well with everything else, and they can build their own layout containers that support all of the existing controls. XAML is a declarative instantiation language. We talked about that. Now, one thing I didn't talk about is how you hook this all up with code. When you name an object in XAML, when you give it an ID property, that object shows up as a class member of your generated code. Now, it's .NET language independent, so this might be C# generated code, it might be VB.NET, it might be any of the .NET languages. So the manipulation via the object model, because XAML is just an object instantiation language, is completely consistent with XAML. So I can name an object, and then I can modify its width property later on in code, even though I've declared that property, that object in XAML. And furthermore, you can also construct objects entirely through the object model in code and serialize them out through XAML for the same reasons that we just talked about. So this was a demo that I was going to do if I had time. And I think I do have a few minutes to do this. But before doing that, let me just talk about there's an awful There's an awful URL to take you directly to Avalon. Don't worry about that one. Go to msdn.microsoft.com/longhorn. Look for Avalon and WinFX. WinFX is the broader runtime distribution that Avalon is a part of. Beta 1 is going to be this fall, and the release of Avalon as part of WinFX is going to be in 2006. Available on XP and Longhorn as well. So this is the C# Express edition of Visual Studio. It's basically the entire Visual Studio integrated development environment that only has support for the C# language. There's versions of this for VB and C++ as well, and of course the entire Visual Studio environment is available. So this is a very simple application. It just has, here's the XAML. It's got a grid in here with a button that has a height and width and a font size and a background color and some content, and a button click event handler. Let's just run this. So that's how it was initially constructed, and I'm going to show you the code that makes it do this. So when I gave this X:Name MyButton, that resulted in a MyButton object being created. So now, when I provide this button click method, whenever I click on that, I can say MyButton dot, and it has all of the methods and properties available on a button. So I'm going to set MyButton dot. I've just got a Boolean flag, static Boolean flag, and based on that, I say hello or goodbye. Again, based on F, I set it to yellow or green as the background, and then change F to the opposite. So that's that entire application. The point of showing this is the ease with which code and markup is how you move easily between code and markup. Again, through the use of declaring a name, and event handlers represent methods that are going to be invoked in the class that's associated with what we see here in the XAML. So that's it for me, and Steve and I can take questions the next few minutes. Yes? Yeah, yes, I'll repeat the question. The question is, what exactly is the relationship between the XAML and the Visual Studio generated stuff? Well, one of the new features in C# and VB.NET is the notion of partial classes. So partial classes means that the class can be defined here and provide some of its methods and properties, and elsewhere in other files and define some of them. The way the XAML development environment works is the existence of this XAML construct results in the rest of the partial class that defines the member variables and other things. And then the user-written part can just refer to those. So this, what you see here is developer-written entirely, and then there is some other chunk that's compiler-generated, more XAML compiler-generated. Yes. Oh.
Yes. Was that that little example that you just showed there? Was that was the actual layout done by the Visual Studio designer? And did that generate the XML code, or
no?
Exactly. Or did you generate that XML code yourself?
In this case, this was handwritten.
Okay.
I talked about the XAML markup being very designable and good for tools to construct and edit. Currently, there's no announced availability of any Visual Studio or tools stuff. It's clearly something we're interested in working on, and other companies are working on it as well. Yes?
I've got one gripe and one question. The gripe is installing this for the newer versions I've found to be very difficult if you have some of the old versions installed. Is there other, well actually it's a question I guess, other plans to make that any easier to actually install the next versions? Secondly, it seems to me that when you run 3D through Avalon in the browser, it seemed to be a little bit slow. Are there any plans to speed that up, in fact?
So regarding the first, I have also heard the difficulty of uninstalling earlier versions. I don't know. I'm sure it has been heard. I don't know exactly what the plan is for that. 3D in the browser, which browser you're referring to? Yeah, I'm hesitating because I don't know the current answer on that. Part of the reason for that is that it's difficult to get a hardware accelerated surface from the browser structure. So I don't know if that's been resolved or not. Any other question? Yes?
I'll take it. I mean, I'm impressed by the power and functionality in the 3D. And certainly all of us who have tried 3D, there are some things that work, that are appealing, that are eye-catching, other things that are disturbing and unsettling. The disorientation, as you pointed out, as things swirl behind you in those photos, or the tilted images, the tilted screens that become more difficult to read as you get past a certain angle and the readability deteriorates. Do you have a list of advice or guidelines for users as to what are the things that are really good strategies and what are the things that they should be avoiding?
Yeah, that's a good point, and there's some work on that across Avalon, and 3D is a big aspect of that, certainly. I don't know if we've got a list right now. We've talked about providing that. We are providing the platform as broadly as it is, so that other groups like Steve's group can help limit that and send that in the right direction. Because even after all these years, it's still not clear.
Right.
Where that needs to go.
Anecdotally, at least some of the things I've found is limiting your camera movement. People don't tend to like camera moves a lot. I mean, zooming in and zooming out is about the limit. It's, well, no. That's some of the things. When you have too many things moving in too many different directions along the screen, that's also very disorienting. So we've tried to make it so that, again, these are anecdotal. We could design some studies, and it would be interesting in doing those. But those are some of the things that we found.
I think that's a discussion that's interesting. I guess also I wonder if there's a list of things that haven't been done yet. Or, I mean, there are a lot of interesting interface features like synchronized scrolling that we don't see. And you have, in these cases, it's sort of interesting that the tools you use rather have a limited view, and you had even the difficulty of horizontal scrolling. So there would be innovative strategies that would facilitate the developers' tools as well. Have you got a list of those fantasies of where you want to go with it?
I mean, I definitely do. Part of my thinking is that there are certain things in performance that affect all of these things. You can't even test out some of these ideas if you can't really get smooth motion on this. So that's one of the reasons why I'm excited that, one, we have a performance system, and two, that we can rapidly change those ideas. Because I really believe that you have to try these user studies. Your user study population changes over time, and you have to retry them and try out the new ideas. So I have a number of different ideas. We'll take a lot of that offline. But
there's also, kind of in response to that, there's also an effort to define design standards, as is always the case with Windows applications. And there's sort of a branch with the introduction of Avalon, in the sense that there will continue to be, the majority of applications we imagine will want to have a traditional sort of Windows forms-based UI, which is still can leverage all the resolution-independent features of this that might not have a lot of animation, for example. But so there's this concept of a traditional kind of forms-based Windows-branded app, which is, most enterprise applications, for example, might conform to this. But now there might also be an example of an application that might be a Coca-Cola-branded app or a more sophisticated visual language. And in that case, they can be empowered by the underlying visual architecture. One of the reasons why we wanted to plan this session is because in just our anecdotal analysis of both inside Microsoft and externally with academic research partners, that there are literally hundreds of platforms and toolkits for designing non-standard controls. So I think we recognize that most of the controls will continue to be conventional and take advantage of radio boxes and list boxes and things that we already all know and understand. But there's lots of opportunity for UI exploration with novel controls. One of the reasons why I've been so supportive of Piccolo, for example, Piccolo.net, is because it's really a beautiful on-ramp for being able to quickly prototype novel custom controls in .NET. Avalon is really, as you can see, a very ambitious kind of fundamental architectural exploration of how do you build a very flexible interaction platform and toolkit based on this. So I think we're almost out of time. I think we probably have time for just one more question. So let's do that. Yeah.
Well, each time we develop one of these new user interface technologies, there's a potential of locking a lot of presentation material away from people with disabilities. So exactly what efforts is this project making to make sure that it's inclusive from the start?
Yeah, that's a great question. The question is about what support is there for accessibility aids for applications that are built using Avalon. For the Longhorn effort, and I believe for XP, but at least for the Longhorn effort, there are, in fact, additional opportunities here because there's user interface automation that is provided, a group called UI Automation, a technology called UI Automation, that's going to allow the discovery and traversal of these trees that are constructed by third-party accessibility applications that can then have a higher level semantic understanding of the content that's part of these trees rather than what the underlying graphics primitives that had previously been the case. So we think we've got a good story there in terms of moving forward. Yeah.
I also think if you pay attention to usability needs, it often gives you great advantages in designing better apps for everybody. I mean, this is an example. Ben's used and Bill Buxton's used. Now, the ramps for handicapped accessibility are used by strollers and by bikes and all sorts of other things that weren't anticipated. It's very similar to paying attention to that early on in the process, and you get a lot of enhancements for everybody.
I noticed your project would be great for adding a lot of alt tags quickly.
Yeah.
I also want to follow up on what John said, and there is a lot of power here with Avalon and a lot of opportunities for UI innovation. So, this room I expect will also, potentially be using it and discovering the right directions and the things that work, the things that don't work. And I think that's great.
In fact, that was one of the examples of where our academic community engagement has really helped to drive the charter of Avalon, because there's, just in this room, there's many people who are doing novel user interface exploration, and right now it's somewhere between challenging and painful, or more often you have to architect your own. I mean, every every user interface person that I know either uses or builds their own kind of interaction toolkit. So this might enable rapid prototyping across a wider kind of user population, and also taking advantage of acceleration, which is key. So that's the conclusion. But if you have any additional questions, I certainly welcome you to engage throughout the course of the faculty summit with Steve or Greg, and kind of have a more open dialogue about user interface. We continue to be very interested in the ways that our academic research partners want to push Avalon as a core technology and Windows as a user interface prototyping platform in general. Thank you very much for your time.